Hi, welcome to lesson 6 of vectors. Today we're going to look at 3D vectors, but before we look at the 3D vectors, we need to look at 3D coordinates. So let's move on to the next slide. So here we're really just extending our knowledge of coordinates in 2 dimensions into 3 dimensions. So for 3D coordinates, we have an X, Y and Z axis. Now, if you imagine your normal coordinate diagram with your X and Y axis drawn on a sheet of paper and lying on top of your desk, this will create the horizontal plane of the three-dimensional grid. So in this case, the X-axis moves left to right just as normal. The Y-axis, if you imagine it, is almost going forwards and back, so it's into your page and then back out of the page. It's represented by a diagonal line, and that's to give it a sense of perspective, as I said, sort of into the page and out of the page. If you do art or graphics, you may already be used to this. And then the Z-axis is the axis that gives us height, so it moves up and down. So the direction of the arrow indicates the positive direction. So we can see here that in the x-axis, the positive direction is to the left. No, it's not, it's to the right, sorry. And the negative direction is to the left as normal. For the y-axis, the positive direction is moving forward and the negative direction would be moving backwards. So that's kind of towards yourself, if you like, out of the page. And then for the z-axis, the positive direction is moving up and the negative direction is moving down. If we want to plot a point, then we just plot it in exactly the same way. It's alphabetical. Okay, we seem to chop off the last wee bit of the last slide there, so I just want to recap that 3D coordinates are written alphabetical, so that would be X, Y, and then the Z coordinate. Also remember, if you think back to your two-dimensional vectors, a column vector would be written X, then Y vertically. So similarly, a 3D column vector is just the same as the coordinate, but written vertically X, Y, Z. So let's have a look at some examples. Example 1, we're asked to plot the point 2, 3, 6. So starting at the origin, that means we're going to go right 2, forward 3, and then up 6, since these are all positive numbers, and that would give us the position of our coordinate P. If we look at example 2, we have the coordinate Q, which is 7 minus 2, 4. So that would mean starting at the origin, we would go positive 7, so that would be 7 to the right, so 7 along the x-axis. We would go negative 2 in the y direction, so that would be 2 back, so that's out of the page, if you like, towards yourself, so minus 2, and then we're going positive 4 in the z direction, so that would be 4 up, and that would give us the position of our coordinate Q. So here we have example 3, and this time, instead of being asked to plot the points, we are being asked to write down the coordinates of the given points and their corresponding column vectors. So let's look at A. Here we can see from the origin we need to go right 1, then we need to go forward 3, and then up 5. So they're all in the positive direction, so that gives us a coordinate of 1, 3, 5. The corresponding column vector, remember we write this with lowercase r underlined, would be 1, 3, 5 written vertically. If we look at B, the example we have here, from the origin this time we need to go 4 to the left, so remember left is the negative x direction, so we would need to write that as negative 4. Then we need to come 2 back, so again that's a negative direction, so that would be minus 2 for the y component. And then we're going 1 up, so that's the positive direction, so that would be positive 1 for the z component. So this gives us a coordinate of negative 4 and negative 2, 1. Similarly, the corresponding column vector would be lowercase s underlined, -4, -2, 1, but written vertically. Okay, so this is the last example before you guys are going to go away and have a shot yourself. But I really just wanted to highlight something you needed to be aware of. In all the examples I've already given you today, the questions were given in the standard orientation. And what I mean by that is that the x-axis was going left and right, the y-axis was going forward and back, and the z-axis was going up and down. However, occasionally you may come across a question where the orientation of the axes has been swapped about. The majority of the time it's the y and the z axis, as in the example below. So you need to be aware of that. So we really just want to make sure that you check the orientation, always check the orientation of the axes before you begin the question to make sure that they are in the standard orientation. And if they're not, then remember that you always go alphabetical. So you're always working X first, then the Y direction second, and then the Z direction third. So let's have a look at this example below. We've been asked to write down the coordinates and the column vector for this point T. So if we look at it starting at the origin, we need to go 3 to the right, so 3 in the X direction. And then the next bit is where we need to watch out, because remember it's the Y direction next. So this time we're going -2 in the Y direction. So the Y direction is -2. And then in the Z direction, we are going +3. So in this case, it will give us a coordinate T of 3, -2, 3, and a corresponding column vector of 3, -2, 3. Okay, so just be aware of that. Just always double check the orientation of the axes before you begin the question. Right, now it's your turn to have a go. Okay, time to check if you understand what we've done so far. So if you can pause the video please and go to Vectors Worksheet Exercise 6 and complete question 1A to R. It sounds like a lot, but you're literally just writing down coordinate points really and the column vectors for that question. Once you've done that, check and correct your answers and then return to the video to move on to the next part of today's work, please. Okay, so let's look at 3D vectors, and it's really straightforward. It's actually just the same, just like 2D vectors. So we name them in exactly the same way. We use the same symbols to name 3D vectors. The column vector is just like the 2 dimensions, only it's got an extra value in it. So the column vector is x, y, z, as we say, seen on the previous slide. And then the magnitude, to get the size or length of the vector, we just extend our Pythagoras to 3 dimensions. So instead of it being the square root of x squared plus y squared, it's the square root of x squared plus y squared plus z squared. So it's just that extra little bit in the column vector and in the magnitude formula. So let's look at the example we've got here. A point P has been given, which creates a vector from O to P, and that has been labelled with A underlined. So first thing, if we look at the coordinate, we need to go 2 to the right from the origin, then 3 forward, then 6 up. So our coordinate point P is the point 2, 3, 6. The vector from the origin to P, we would call that OP with the arrow above it, remember, or A underlined in this case, and that would just be 2, 3, 6 written vertically. To get the length of the vector OP, then we need to use that magnitude formula. So we do the square root of the components of OP, so that's 2 squared plus 3 squared plus 6 squared. And if we work that out, we get the square root of 49, and we know the square root of 49 can be written as a whole number, so that's equal to 7 units exactly. Okay, if you can pause the video here and have a go at these questions. So using what you've just learned in the last slide, we want to write down the coordinates of each point and their corresponding column vector, and then calculate the magnitude of each one as well. So pause the video here and have a go. Okay, let's have a look at question 1. So here, from the origin, we need to go 4 to the right, 1 forward and 5 up, so that gives us a coordinate of 4, 1, 5. The corresponding column vector would be OP, and that's just written 4, 1, 5 vertically. The magnitude of OP then is the square root of 4 squared plus 1 squared plus 5 squared. So working that out, we get the square root of 42, and if you haven't done simplify and surge, you can write it as a decimal, which would be 6.48 units. If we look at the second example, here from the origin we need to go 2 to the left, so remember that's the negative direction. We need to come 1 back, so again that's the negative y direction, and then we're going 3 up, so that's the positive z direction. So that gives us a coordinate of -2, -1, 3. Likewise, the vector, the component vector of OR then would be -2, -1, 3. And then lastly, the magnitude of OR would be -2 squared plus -1 squared plus 3 squared. And working that out, we get the square root of 14, which would simplify to 3.74 to 2 decimal places. Okay, so that wasn't particularly difficult, short and sweet there. So if you go back to the vectors worksheet exercise 6, please, and complete examples in question 2. Check and correct your answers and then come back to the video for the remainder of today's work. Okay, so we're at the last part of today's lesson and we're going to look at a couple of exam type questions. When we're doing these questions, the important thing to remember is your shape properties. Here we've been given a cuboid and we've been told that H is the centre of the face ABEF and J is the centre of the face BCDE. Now with a cuboid you should remember that opposite edges are equal in length and parallel to each other. This will help us when we're trying to find the coordinates of H and J. The other piece of information we've been given on this diagram is that the coordinate E, to get to the coordinate E from the origin, we need to go right 6, forward 4 and then 2 up, and this will help us identify the other coordinates. So firstly we've been asked to identify the coordinates of point H. So to get to H we need to go from the origin along to A, and then from A we need to go along halfway along the edge AB. Now we already know from the coordinate E that the edge AB has a length of 4. If we're only going halfway along that, therefore we're only coming along a distance of 2. So the y component of coordinate H is 2. And then lastly we need to go up. So we're going in the same direction as edge BE, which has a length of 2, but we're only going halfway up, so therefore we only need to go up a distance of 1. So that gives us the Z component, the height of point H. So therefore H has the coordinate points 6, 2, 1. Now we'll look at J. So to get to J, we need to go halfway along the edge OA. Now we already know that OA has a length of 6 because that's the edge that we first need to travel along to get to point E. So if we're only going halfway along, we only need to go a distance of 3. So that gives us our x component, or x coordinate of coordinate J. Then we need to go all the way forward the same distance as coordinate E, so therefore we're going forward 4. So that gives us our y coordinate of J. And then lastly, we're going up only 1 again, the same height as H, or halfway up the height of E. So therefore the coordinate J is 3, 4, 1. Okay, let's have a look at a second example. So in this second example, we have been given a rectangular based pyramid, and we're told it's shown relative to the coordinate axes and being asked to write down the coordinates of the point B and calculate the length of the vector AV. So remember, if we want to calculate the length of a vector between 2 points, we need to work out the vector between 2 points. So if we were doing the vector A to B, it would equal the components of vector B subtract the components of vector A, or the column vector of B subtract the column vector of A. And once we've got that, then we just use our Pythagoras. So let's work our way through this question first of all. So here we've been asked to work out the coordinates of B. To get to B, we need to go from the origin along to C, and then from C along to B. There is no movement vertically, so there's no movement in the Z direction, so therefore the last coordinate will be 0. So we need to concentrate on the first 2 coordinates. So let's have a look at that. Now we know from coordinate V that we need to go along 5 to get to the middle of the base of the pyramid. But we also know that the coordinate point A is 2, 0, 0, so we need to go from the origin to get to A, we need to go along 2. So from that we can see that from A to the middle of the edge AC is a distance of 3. Now that's halfway along that edge, so therefore we need to go a further distance of 3 to get to C, which means altogether from O to C is a total distance of 8. So our x coordinate of the point B is 8. We need to go 8 along first of all. Then we need to go from B to C. So again, from the point V, we know that from C, halfway along the edge CB is a distance of 2. So therefore we need to go another further distance of 2. So altogether that will be a distance of 4 to get to point B. So our y coordinate is 4. And then as I said earlier, there's no vertical movement here, so therefore the z coordinate is 0. So for B we have the coordinate points 8, 4, 0. Okay, let's look at part B. So for part B, we know that coordinate point A is 2, 0, 0, and we know that coordinate point V is 5, 2, 6. If we want to get the length of that vector, we need to work out the column vector for AV first of all. So remember, the distance between 2 points, so AV is the second column vector, subtract the first column vector, so it's V minus A. So here that would be 5, 2, 6, subtract 2, 0, 0, and that gives us a column vector of 3, 2, 6. So the column vector for AV is 3, 2, 6. Now once we have that, all we need to do is our Pythagoras. So the magnitude of AV is the square root of 3 squared plus 2 squared plus 6 squared, and if we work through that we get the square root of 49, which in this case is 7 units exactly. So the magnitude or the length of vector AV is 7 units. Okay, now you can go back to Vectors Worksheet Exercise 6 and complete questions 3 to 7. Check and correct your work at the end from the answers, and then don't forget to upload your work to your class notebook. And that's you finished for today. Thank you.